Number 1 gives us two inequalities that are graphed on the same coordinate plane. Which region represents a solution to the two inequalities? And so we've got region A, B, C, or D. And if it's a solution to both inequalities, okay, so for the system, that means that it's going to be where they're both shaded. So where we see these lines and this shading, so that's going to be here in region D. Number 2, select all pairs of x and y that are solutions to this system of inequalities. So we're going to want to plug these into each equation. Remember, if it's a solution to the system, it needs to be true for both, not just one or the other, but it must be true for both. So we're going to go ahead and plug into this top equation here. So we're going to plug 0 for y. So we're going to see if 0 is less than or equal to negative 2 times 0, which is 0, and then plus 6. So this one says that 0 is less than or equal to 6. That is true. So then we'll plug into this bottom equation. So we'll plug 0, 0 again. So 0 for x minus 0 for y, is that less than 6? So is 0 less than 6? That's true. So that means that A is a solution to both, and that means it's a solution to the system. So we'll go ahead and go to the next one. So we'll plug in. So this one says y, which is negative 15, is less than or equal to negative 5 times negative 2 is positive 10 plus 6. So is negative 15 less than or equal to positive 16? That's true. So we'll move to the next equation. So we're plugging negative 5 in for x. So negative 5 minus negative 15. So that's going to be plus 15. Is that less than 6? So really, is 10 less than 6? And that is false. So B is not a solution. Part C, again, in the top equation, the y value is negative 2. Is that less than negative 2 times 4, which is negative 8, plus 6? So this one says negative 2 is less than, or equal to negative 2, and that's true because it's equal to negative 2. So then we'll plug into the bottom one. So our x is 4 minus our y, which is negative 2. So it'll be 4 plus 2. Is that less than 6? So this one says 6 is less than 6, and that is false because it's equal to 6. Part D, again, 0 for y, less than or equal to negative 2 times 3, so negative 6, and then plus 6. So 0 is less than or equal to 0. That is true since it's equal to. So then we need to plug into the second equation. So x in this case is 3, minus y, which is 0. And is that less than 6? So this one says 3 is less than 6, and that is true. So it's true to both. So it's true to the system. And then the last one, 0 for y is less than or equal to negative 2 times 10, which is negative 20, plus 6. So is 0 less than or equal to negative 14? And that is false. And so we don't even need to plug it into the second one if it's false to the first. Number 3, Jada has $200 to spend on flowers for a school celebration. She decides that the only flowers she wants to buy are roses and carnations. Roses cost $1.45 each, and carnations cost 65 cents each. Jada buys enough roses so that 75 people attending the event can take home at least one rose. write an inequality that represents the constraint that every person takes home at least one rose. So if we call the number of roses she gets R, we just need to make sure that we have greater than or equal to 75 roses. So if we have equal to 75, everybody gets one. Anything above that, people would be getting more than one. And now let's write the cost constraint. So this uses the money. So she's spending $1.45 per rose, plus she's spending 65 cents per carnation. And she needs to spend no more than $200. So she can spend less than the $200 or equal to it. Number 4, here's the graph of these two equations on the same coordinate plane. Let's label each graph with the equation that it represents. So these, to me, are in standard form. So I'm just going to solve for the x and the y-intercept. Since the x's are the same, I'm going to look at the y. So let's plug 0 in for x for this one, and we get y equals positive 9. So that means this one's crossing at positive 9. So that means that this equation here is that graph. And then you can label it on your paper by writing next to it like, 3x plus y equals 9 is for this one. Then for the next one, obviously we know which one it is now, but I can still check it out by plugging 0 in for x. We get negative y equals 9. So then that means that y equals negative 9, which is this equation here. So then we have this one is the equation for 3x minus y equals 9. Part B says, identify the region that represents the solution for 3x plus y is less than 9. So for this one, we're now changing this equation into being that 3x plus y is less than 9. So you know me, you know I'm going to plug in 0, 0 to check what the region. So then we're going to get 0 plus 0 is less than 9. 0 is less than 9 is true. So that means that I'm going to shade below this line as the solution to that inequality. And then it asks, is the boundary line part of the solution? And the answer to that is no, because it doesn't have the equal sign. So that equal sign is not there. So then I'm going to go ahead and change this to a dotted line because that's not part of the solution. And then they want us to repeat this with the other one. So now we've got 3x minus y is less than 9. So I'm still going to plug in 0, 0. So 0 minus 0 is less than 9. 0 is less than 9 is true. So now when we're looking at the orange line, 0, 0 is part of the shading. So we're going to shade above that orange line. So all of this above that orange line is shaded. And then it again asks, is the boundary line part of the solution? And again, no, because we don't have that equal sign underneath it. So the boundary line is going to be a dotted line. So I'll switch this to dotted. So then it says identify a point that's a solution to both of these inequalities. So remember for this, we want to find a point that's being shaded by both the blue and the green lines. So anything over here. So anything here, okay, above this orange and lower than this blue. So this kind of green region here is the part that's shaded by both. So anything in here. So you could pick this ordered pair, which is negative 6, 6 would be fine. Okay, you could pick negative 8, 0. Okay, literally any point. Let me just draw a point. literally any point in this region. So you could pick 1, 0. You could pick 0, -2. Okay, you could pick anything over here. Any of these ordered pairs is fine. Can't pick this one because this one's only in the blue shading. Can't pick this one because this one's only in the orange shading. You can't pick something on the boundary line. So can't pick here, can't pick here. And also obviously can't pick over here. So anything over here. Number 5, which coordinate pair is a solution to this inequality here? So I'm just going to write this out. 4 times x minus 2 times y needs to be less than 22. And we're just going to plug these in. So 4 and -3. So 4 for x, -3 for y. So we end up for this one, we get 16 plus 6 on the left, which is 22. And is 22 less than 22? No. Okay, that's equal to 22. So that one's false. So we'll plug in the next one. So we'll plug in 4 and 3. So 4 and 3. So we get 16. And now -2 times 3 is -6. So that's going to be 10 is less than 22. And that is a true statement. So we know that one works. And it just said which coordinate pair. So we're only picking one answer here. If you're like me and you want to check it out anyways, you could do 4 times 8, which is 32, and -2 times -3, which is +6. 38 is definitely not less than 22, so that one's for sure false. And then we could do this one. 4 times 8 is 32. -2 times 3 is -6. So then we get 26 is less than 22, and that's also false. So for sure, B was the only one there. Number 6, consider this linear equation. The pair 3, 5 is a solution. Find another pair that's a solution. So I would suggest just picking an X or a Y. And I don't know if you want to plug in 0. That's pretty easy. So plug in 0 for X. So when we plug in 0 for X, we just get 0 minus 3y equals 12. So we really just have -3y equals 12. So then we can divide by -3, and we get that y equals -4. If you wanted to do it like that. You could also pick a different number. You don't have to pick 0. So another one that you could do, so I'm just going to clear this and just do it again. So another thing you could do is, let's say I just wanted to pick 2 for x. So 2 for x gives me 18. And then we have minus this number equals 12. And so for here, if we want this to be a solution, we know this space needs to be 6 or -6, right? So I know that whatever I put here needs to make this be -6. Well, that's going to be a 2 as well, because -3 times 2 gives you that -6. So that's a couple different ways you could look at finding a solution. Then B says, are 3, 5, and 2, -10 solutions to this inequality? So for this one, you're just going to need to plug them in for x and y and see if you get less than or equal to 12. So if we plug in this one, 3 for x and 5 for y, we'll get 27 minus 15. 27 minus 15 gives us 12. Is 12 less than or equal to 12? And that is true. So this is a solution. Then we can plug in the next one. So we can plug in 2 and then -10. So 9 times 2 is 18. -3 times -10 is +30. So that's going to give us 48. And 48 is definitely not less than or equal to -12. So that one is not a solution. Number 7, Elena is considering buying bracelets and necklaces as gifts for her friends. The bracelets cost $3 and the necklaces cost $5. She can spend no more than $30 on gifts. So write an inequality to represent the number of bracelets B and the number of necklaces N she can buy. So remember, it's $3 per bracelet. So 3 times every bracelet, so 3B, plus $5 per necklace, so 5N. And she can't spend more than $30. So she has to spend less than $30 or equal to it. So there's our inequality. Then it asks us to graph this. So I'm going to graph by the intercepts. And the intercepts really in context mean that she's only buying bracelets. So if she buys 0 necklaces, how many bracelets does she have to buy? And we would just do an equal sign here. So then divide by 3, and we would get 10 bracelets. So if she buys no necklaces, then she's buying 10 bracelets. Similarly, if she buys no bracelets, how many necklaces would she have to buy to get to 30? And so then we could divide by 5, and we get that she would have to buy 6 necklaces to equal out to that $30. Then we can just graph this line, and remember that she's allowed to spend $30. So it's fine for this line to be equal to $30, which means I'm going to keep a solid line when I connect this. And then she's going to spend anything less than this $30. So she's going to be in this region here, will be the shaded region. So anything on the boundary or below that line will be solutions. And then it says, explain how we could check if the boundary is included or excluded. And I would just say by seeing that it's equal to 30, right? So this one says equal to $30 is okay, because $30 is her limit. She can spend that, but not more than that. You can also take and plug in a point and see, but the idea is going to be the same here. When you plug it in, you're going to end up with, so 3 times 4 in this case, plus 5 times, or wait, is that, I picked the wrong number here. So this ordered pair is 3, 4. So she's buying 3 $3 bracelets and 4 $5 bracelets. Is that on the line? Must not be on the line, because 3 times 3 is 9 plus 20 is $29. So that one's not on the line. We do know the 6 is on the line, right? So you could plug in 0, 6, which is what we did right here, and we got 30. So you end up with 30 equals 30. So I don't know. I just feel like looking to see if it's okay to equal the limit or not is fine as well. Number 8, in physical education class, Mai takes 10 free throws and 10 jump shots. She earns 1 point for every free throw she makes and 2 points for every jump shot. The greatest number of points she can earn is 30. So write an inequality to describe these constraints. So these numbers up here are pointless to this. This is just the number of shots she can take. So she's going to stand at the line and shoot 10 free throws. But the 10 doesn't have anything to do with the constraints, because what we're looking at is how many points she gets. She gets 1 point per free throw she makes. And then she gets 2 points for each of the jump shots she makes. And we know that this is going to be less than or equal to 30 points, because if she had hit all 10 free throws, she'd get 10 points. And if she had hit all 10 jumpers, she'd get 20 points. That's where that 30 is coming from. But so the number of shots she makes or the points she gets has to be less than or equal to 30. So then name one inequality and explain, or one solution and explain what it represents. So now here's where you would pick numbers less than 10 for both of these, right? So I'm just going to say, let's say for the free throws, she makes 8 of them, and for the jump shots, she makes 4. So then we would have the points that she would make would be 1 per free throw and 2 per jump shot. So, and then that's going to be less than or equal to the 30. So she made 8 free throws and 4 jump shots in mine. So that's saying she made 8 points for the free throws and 8 points for the jump shots, which was 16, which is less than or equal to 30. And what it means is she made 8 out of 10 free throws, and she made 4 out of 10 jumpers. All right, then last one, number 9, a rectangle has a width of W and a length of L. The perimeter is greater than 100. Here's a graph for this situation. Write an inequality that represents this situation. Now, for this one, you want to remember that perimeter has a formula. So when you have a rectangle, so if I draw a rectangle, we've got the length and the width, but perimeter is adding up all the sides. So we actually have 2 lengths plus 2 widths for the perimeter. So the inequality for this is that 2 of your lengths plus 2 of your widths needs to be more than 100, not equal to 100, greater than 100. So then it says, can a rectangle have a width of 45 and a length of 10? So 2 times 10 plus 2 times 45. So that's going to be 20 plus 90. And is that greater than 100? And it is. So 110 is greater than 100. So that is some dimensions that can work. Then there's another problem that isn't on here, but it says, could we have a width of 30? So could the width equal 30 and the length equal 20? And so then we would again just double each of these, right? So we would do 2 times 30, and we would do 2 times 20 and see, is that bigger than 100? So this is going to be 60 plus 40, which is equal to 100. And 100 is not greater than 100. This is false. It's equal to 100. So this would be no. So yes, you could have 45 and 10, but no, you couldn't have 30 and 20. And you can look at this graph here too. So you can go to 45 and then 10 and see that that one worked. And let me make that blue. So this is the 45, 10. It's in the shaded region. And then the width of 30 and the length of 20 we see is on that boundary. So then 30, 20 would be no, since it's on the boundary versus the shaded region.